Welcome to Cybersecurity from Scratch, Technical Foundations, Episode 6, Public Exploits and ExploitDB. We're going to start with a little bit about the exploit publication process, and then dive into a series of demos where we show off how ExploitDB can be used to check for exploits for particular CVEs, how we can find Metasploit modules that correspond with CVEs, how to modify some exploits, and then how to look online for other publicly available exploits and to get a sense of which ones should actually be used in a pen test. We'll use the SearchExploit tool embedded in Kali Linux to find exploits that are available on ExploitDB. And then finally, on the blue team side, we'll look at this knowledge and see how we can use it to evaluate what CVs we should be worried about. First, a bit of vocabulary review. An exploit is any software-based attack which takes advantage of a weakness or defect in a system. And a CVE is a critical vulnerability exposure, which is a way of universally tracking exploits so that when you're talking about a particular weakness in a system, you know exactly what's being discussed. Now, the way that exploits are supposed to be disclosed is that researchers will find a weakness in a product, report it to the vendor, and then give them some amount of time to fix the problem. Then once the problem is fixed, or the vendor has said they're not going to worry about it and they don't care, then the reporter is able to publish on the matter of the exploit. And the reason they do this is often to get some sort of notoriety and otherwise promote themselves or their business because, they clearly are good researchers since they were able to gain that information. Now, oftentimes this isn't what happens. Sometimes the weakness will be discovered by an unscrupulous party and they'll just sell the information on the black market, and that can be used for all sorts of bad things. However, when the vulnerability is properly disclosed, it usually ends up, if it's a particularly useful one, on ExploitDB, which is sort of a central clearinghouse for exploits maintained by Rapid7, or sometimes if it's a custom version of the exploit tailored for some particular application, or if it's just a less popular exploit that's not needed as often, the main canonical source of that exploit, if you will be the GitHub page of whoever the author is. So going to these resources and learning how to use them is very important for pen testing because that's how the tester will get the exploits that they're actually going to be testing. Exploit database is the first place to check for exploits during a pen test or capture the flag exercise. It's also searchable by the SearchExploit tool inside Kali Linux, which we'll take a look at later. Now first, if you're up here on ExploitDB, you can search for what you're looking for with this search icon. You can look by title, you can look by CVE number. There's the different types of exploits that are available, including actually papers that have more of a general write-up on different steps that you can take, target platform, etc. It's a very feature-rich environment. These papers in particular can be very useful as they'll sometimes include rather detailed explanations of different type of exploits that can help you get a more theoretical understanding of a particular attack vector. There's many different types of exploits as well that are a little more concretely implementable, such as this exploit right here, which is a complete exploit program disclosed last August, and it can simply be run. The whole exploit is right there. And then in other cases, the exploit is more of a listing of steps that need to be taken. In this case, this is a cross-site scripting vulnerability where the discoverer has simply documented what it takes to recreate the exploit. Now, we don't necessarily need to go to the website to find what we're looking for. If we know, for example, in the episode we gave in a prior episode that there's a Samba vulnerability, or at least we suspect there might be one, we can search with the SearchExploit tool for Samba. And in this case, Samba has a lot of vulnerabilities over the years. So depending on which version you're looking for, you can kind of take your pick. In this case, I know that I'm looking for a particular item since I've sort of scoured through these already. And I can use this -x flag and then the ID number for the exploit, which you can see in the path name over here, to pull up the exploit that I want. So this -x flag basically lets me read in console the exploit. And so I can see here that it's a Metasploit module. and I see the user map name here. So I would, to use it, exit out, fire up MSF console. And then I can search for user map, and there it pops up. So I would say use 0. And again, just to review what we did previously, show options. We're going to give our own IP. Let me show the options again. So we've told it where to attack, who we are, so that we can capture that return shell. And we launch the exploit. There we go. All set. Understanding how an exploit works is of course vital for safety. You don't want to accidentally get yourself hacked, and you certainly don't want to introduce malware that you don't intend to into a client. That's a really terrible way to end up messing up your contract. You also sometimes need to modify the exploit. So say, for example, I was doing a capture the flag exercise a little while ago against a system vulnerable to Eternal Blue, and I was not returning a shell. So it turns out that the system was configured in such a way that it wasn't vulnerable to having a shell returned. But I could still get code executed as an admin. So my next thought was, of course, I'll just create a user. So I searched around for a version of Eternal Blue which would create a user, and I found one on this GitHub page right here. However, when I went to use it, I found it was missing something important. Now, normally when you're creating a user and you want to be able to get administrative access, it's a simple matter, as you see here, of adding the user and then adding them to the administrators group. Ta-da, no problem. However, in my particular context, I needed to remote into the system. And to do that, I needed to add the user as well to this remote desktop users. So to do that, I had to pull down the exploit, read and understand what it was doing, and then modify it appropriately to include my own content here. So if you want to see a diff of that, basically it's using a git diff here. We can see that I tweaked the exploit to have my own username and password combination, and then adding this line of code here saying that the user would be added to the remote desktop users. This is a good time to introduce the concept of a script kiddie. This is an industry term for someone who's a low skill or training hacker who's simply using tools and exploits out of the box, maybe with a few trivial modifications, but generally is not developing their own exploits and doesn't have the background knowledge to conduct very sophisticated attacks. Defenders, when they're evaluating a CVE, are of course looking at it instead of how can they use it against someone, but to how they can ensure it does not get used against them. And part of looking at a CV and evaluating the risk is evaluating the risks of exploits. One consideration is availability. Can a script kiddie simply find an out-of-the-box exploit for the CV that I'm worried about? Also, if there is one, am I vulnerable to it? Can the exploit be used in my own configuration? Perhaps the port is locked down or a particular module is disabled, or is the exploit requiring some sort of accessibility that doesn't apply to my situation? Perhaps the person already has local access to the system at that point, and perhaps with my security posture, with the assumptions that we have in play, it doesn't really matter at that point. We've already assumed some sort of level of compromise, which is either greater than or equal to what the exploit would give them. So let's make this process a little bit more concrete. A couple of years ago, I had in a system that I was responsible for a CVE that had been reported against one of our software modules, and we were deciding how rapidly we needed to go about fixing it. Now, in order to use this particular exploit, the person would have to have local access to the system and already have compromised a higher level access account, which would allow them to place files in a particular area and relaunch some of our services. At that point, with the permissions that were involved there, the system would essentially be totally compromised at that point anyway. So we still patched the vulnerability, but it's not like we just dropped everything to go make it happen. In that example, it might be tempting to say, well, we had to patch the bug anyway, why does it matter? Timing is actually very important because normally you have a patching cycle where on 30 days, 90 days, whatever it is for your system, you're deploying patches. And if you have to do patching outside of that, you have to pull people from other work. And obviously that's not very efficient, and it means that you're not getting other stuff done. And so if you're able to confine the risk of a particular exploit or CVE, then you can more efficiently use your resources. ExploitDB and other publicly available exploits provide the ultimate answer of whether or not a particular CVE or exploit are something that we need to worry about in our own systems. These checks allow us to do those criticality assessments and see if we really do need to get folks out of bed in the middle of the night to go fix a problem, or if it's something that we can do in a regular patching cycle. It's really the best way to find out is to do the research and get the ground truth on what's the threat. This is valuable because either on a test version of your system or on a production instance, if you can test that way, you can actually fire up an exploit and see if it works against your system in the as deployed configuration. And if it does, you know you have a problem that you need to drop everything and go fix. But if it's something that doesn't affect you or does not provide some effective level of compromise, then you know that it's something that can be patched on a more relaxed cadence. Basically, you're able to test and determine empirically what your real risk exposure is. Now, of course, sometimes there just is no publicly available exploit that can be used to test out if a system is vulnerable or not. Sometimes you have to rely on the guidance in the CVE, where the CVE will say that there's a certain level of criticality and a certain level of compromise, which is theoretically possible. And from there, the organization can make a risk determination on how fast they need to patch. Of course, sometimes it's worthwhile to, not rather than just going off of the published stats in the CVE, dive in and do a little more analysis based off of the details of the CVE publication to see if you can determine through analysis if the system is vulnerable or not. This isn't quite as good, of course, as actually testing it, but sometimes it's the only option when there needs to be a more nuanced risk assessment. The next episode is going to be a big one. We're going to talk about web enumeration and fuzzing. We're going to take the enumeration skills that we discussed previously and adapt them now to be used for scanning and evaluating websites. On the blue team side of things, similar concept where we're going to take the same ideas of reducing our attack surface and containing information and applying that specifically to website configuration.